So I'm Neal, Director of Product Management at a company called Pace Anti-Piracy. Today I get to talk about two things that mean a lot to me: software security and Android development. On the Android development side, the first Android phone that I developed software for was the original Samsung Galaxy. That's right, the one released way back in 2010, running Android 2.1. And if that seems a long time ago, I was developing software security stacks for mobile operating systems a decade before that. So Android development, software security really have been intertwined throughout my career. And the need for security in mobile apps has never been greater. If I was doing this 20 years ago, I've seen the trends emerge and change, and I can say with confidence the need has never been greater for security within the apps. And it's an easy statement to make, but as everyone in this room knows, our lives are increasingly managed through our phones. I'd actually argue we're reaching saturation point where all the services that could possibly be accessible through our phone now are. There's very little you could go on and do that could be brought to your phone. There's apps for everything. That means all that sensitive and often highly private data that defines who we are passes through our phones. Now, I'm not going to insult you by highlighting the need to encrypt sensitive data at rest and in transit. You hopefully know that already. But how do you protect the cryptographic keys that unlock the data? Today, I want to look at solutions to do that, from hardware-backed solutions like secure elements through to pure software ones like Whitebox Cryptography. But before we look at the solutions, let's spend a minute to understand why we need them in the first place. So I mentioned cryptography, and if you look online, you'll find a few different definitions of cryptography, but they all center around the idea that cryptography is the application of mathematical operations to keep information secure by transforming it into a form that an unintended recipient cannot understand. It's a bit of a mouthful, but that's the sort of definition you find if you start looking for one for cryptography. But the key bit, keeping information secure, actually means two things. Firstly, it means keeping the data private. I think everyone recognizes that. But what often gets forgotten is that secondly, we also need to ensure the integrity of that data, making sure it hasn't been corrupted and hasn't been manipulated. Now, at a high level, crypto algorithms, the encapsulation of those mathematical operations we were talking about a minute ago, take two inputs: the data being operated on and the cryptographic key. Not rocket science yet. And in non-scientific terms, these algorithms combine the two together. And the key is important because the key brings a uniqueness that we can control. It stops anyone just running the decrypt algorithm to decipher the data. Therefore, the key is crucial to protect. The key is crucial to protecting the privacy and integrity of the data. If the key can be uncovered, then the data is no longer secure. Well, what does that mean for Android apps? Well, very simply, it means the key can never be in the clear within the application. And this is because mobile apps are vulnerable to reverse engineering. Now, reverse engineering falls into two broad categories: static analysis and dynamic analysis. Static analysis involves cracking the app open and looking at its code. Open source tools like JADX mean that it takes about 5 minutes, yes, literally 5 minutes, to see the code of any Android application. If your secret's in there, an attacker will find them. The counterpart, dynamic analysis, is what you're doing when you're debugging your app. It's looking at the code and the memory while that app is executing. And this can reveal a lot of detail about the application. It's why you use it as a tool to help you debug. So you can see things like the data that's in memory. You can look at the network traffic before it enters the encrypted pipe. And while it requires slightly more skill than static analysis, all the tools and training materials are freely available to download. I like the analogy that if your app's a book, static analysis is reading the book. And if that's true, then dynamic analysis is watching the movie. Or even better, it's playing the interactive virtual reality video game where you get to poke and prod at the world and see what happens, see what falls out. So these techniques make it very easy, make it possible for the bad guys to find secrets you have in your application. So kind of at this point, if there's one thing I really want you to take away from the presentation, it's this. Never have sensitive data, like crypto keys, in the clear, not in code and not in memory. It very simply doesn't take any dark web magic to find them. Just a little time with Google. But thankfully, this problem isn't new. There's technologies that exist, are mature, and well-known, specifically designed to solve it. We're going to look at 3 of the most common options available to Android developers. The first is secure elements. Secondly, we're going to look at the Android Keystore. And third, we'll have a look at Whitebox Cryptography. All 3 have pros and cons, but they all form part of the solutions that we need to be building. So let's start with the historic gold standard, the secure element. Secure element is a tamper-resistant mini-computer, similar to the chip in your credit card. And if you're lucky enough to have access to one, it enables you to install small programs called applets that can safely execute with you knowing that no one can access it or the data it's processing. Now, I did a lot of work in the early days of mobile payments. And in those days, we would have special micro SD cards or use the phone SIM card as the secure element, as the substitute for that credit card chip. And it provided this secure execution we needed. And these days, most flagship phones have a secure element embedded into the hardware. And it's a feature that's working its way down the ecosystem. In 2019, a third of Android phones had a secure element, and that number is growing. Organizations like the Android SE Alliance is pushing new use cases like mobile payments, digital car keys to drive the growth in secure element adoption amongst Android handsets. It sounds good, but I did say all solutions have their pros and their cons. And with secure elements, the challenge comes from the tamper-resistant nature of the secure element. Its greatest strength is also its greatest weakness. For security reasons, access has to be highly controlled. That means it is really only the secure element owner that can have control over it. And that greatly limits the usefulness to the rest of us. If you're the secure element owner, which typically means the device manufacturer, then you have access to a highly secure, quite powerful computational environment. And your organization's already committed to the effort of setting up the ecosystem to manage all those secure elements out in the wild on end users' phones. Great. We have a secure way, a safe way of running our cryptography on the device. But if you aren't the secure element owner, what do you do? Well, Android provides something called the Keystore. Can I have a show of hands? Who's made use of the Keystore in their applications? It's more than I was hoping for. Excellent. And the Keystore provides a container for Android apps to store and generate cryptographic keys and to use those keys in cryptographic operations. A lot of you know this already. You've tried it. But the implementation of the Keystore depends on the phone that it's executing, the app's executing. Some devices will have a secure element. We heard a minute ago, kind of over a third of Android phones now have a secure element in them. Other phones will use a trusted execution environment as a secure area within the main processor, while some lower-end phones will do it all in software. And the Keystore API allows the app to query, find out how the Keystore has been implemented on the phone the app is running. Though, in our paranoid world, where apps can be manipulated, we really need to be careful about trusting OS system calls for security-critical operations. But for me, the real challenge of the Keystore comes as it positions itself as the trust controller. And this is a reality of how it's implemented. The Keystore is really a third-party component to your app, accessed through an OS API. The statement of being a trust controller makes more sense when you look at how cryptographic keys are provisioned into the Keystore. You're given two options. You can either have the Keystore generate the key for you, or you can load a wrapped key into the Keystore. Now, a wrapped key is just a crypto key that is itself encrypted. But guess who generates the wrapping key? It's the Keystore. This means the Keystore is a useful aid to support cryptographic operations that live entirely within the app itself, such as secure local storage, and can be really helpful to anchor device binding solutions to a specific unique device. The Keystore is more cumbersome, though, when it's used to interact with external services, as it starts to put dependencies onto their implementation. With the Keystore, we also have to be aware that the entry and exit point of each cryptographic operation is our app. And that data is going to be in the clear. The apps, as we discussed, vulnerable to analysis while they're executing. So potentially data is exposed as part of that analysis. Now, a good use of the Keystore is running cryptography that's solely contained within your app. As I've already mentioned, secure local storage is a great example. You can generate a key in the Keystore, pass data to the Keystore to encrypt it or decrypt, and that means that data can't be read at rest. It's encrypted. And it can't be decrypted anywhere except on the phone that encrypted it, because the decryption key is locked within the Keystore. Of course, if someone can dynamically analyze your app's execution, they would be able to see the clear text data in memory. So, our third approach is to do everything within your app's code. Now, if you've been following the flow of this presentation, you should probably have picked up that I believe that is a very bad thing to do. It's not a good idea. And you'd be right, to an extent. And this is where Whitebox Cryptography comes in. We call it Whitebox for short. Whitebox technology provides a means to run cryptographic and other algorithms securely in a pure software environment. And that's the key to Whitebox. It's pure software. There is no hardware requirements. And it provides the security by combining the data and the code together. And that data includes the crypto key. Together, with a range of computational and mathematical techniques that means the operation is no longer understandable by a hacker, and they can't extract the crypto key. Even if they can see every execution of the app, every memory read, every memory write, it's still not understandable by an attacker. And as it's a pure software approach, it's very easy to deploy and is very flexible in terms of the algorithms you can run. Even chaining together multiple algorithms so complex operations can be performed without ever exposing data in the clear. I mentioned earlier that I did a lot of work in payments, and we discovered early on that unless you were Apple, Google, or Samsung, getting scale with a secure element approach was hard. There was no universal way of accessing them. The solution was to switch from the hardware-backed architecture security that the payments industry was used to instead use an architecture that was underpinned by Whitebox Cryptography. And that got us the equivalent level of security that the payments industry required and allowed us to satisfy the very high security requirements that we were working to. But, maybe more importantly, it meant we could deploy our apps to any Android phone. And we found the flexibility offered to be invaluable. And we had crypto architectures that could easily fit in with the rest of the app, which is great for performance. And we were in full control of that crypto. We could design flows that meant sensitive data was never exposed in the clear. Even when someone else had already designed the server architecture and the provisioning protocols that we were forced to work to, we could still build secure architectures because we had a fully flexible solution to do that. And if someone was dynamically analyzing the app, they wouldn't see the data. It was always protected. It was never exposed in the clear. A very powerful solution. So where does PACE fit into all this? Well, PACE's technology is all about securing the IP of our customers. That includes providing software licensing services to vendors of high-value software, meaning only authorized users of that software is able to run it, is able to use it. A key part to building a secure licensing platform is to protect our own IP and our own algorithms. To do that, we required software security way beyond traditional obfuscation. We also required flexibility, so the security didn't impact the usability of our products and the usability of our customers' products. We at PACE achieved this with our own Whitebox Cryptography. This technology has been productized into a third-generation Whitebox, a development tool our customers can use to protect their high-value algorithms and data wherever their software is running. So, to recap, it's important to make sure crypto keys are never in the clear. The fact that apps can be reverse engineered means those keys will be discovered if they're in the clear. And we've looked at 3 solutions of how to protect those keys and ultimately protect the cryptographic operations and the data they're operating on. We've looked at secure elements, we've looked at the Android Keystore, and finally, we looked at my favorite, Whitebox Cryptography. Now, we're reaching the end of our slot. So if you want to discuss this more, you want to say hi, we have a table straight through those doors. Keep going, you'll fall over us. Look for the security ninja, you'll find us. So come and say hi, and we'd love to continue the conversation. And remember that you, as mobile developers, are the front line in your company's defense. When traditional obfuscation isn't enough, pace is a good place to start. Thank you.